Hey everyone, this is Professor Capko. Glad you joined us again. Today, I'd like to fight some inequalities. How about you? There's just too much darn inequality out there in the world, and we're going to do our part tonight to fight that. In fact, there's a whole heck of a lot of inequality that you might find on your algebra homework or maybe in your algebra exams. So we're going to find out how to deal with that and how to deal with solving problems caused by inequalities. So you might have something that looks like that. 2x, and it's got this funny looking symbol here, and a 10. Well, this is a greater than symbol. 2x is greater than 10. You can always tell which side is the greater than if you think of it as being an alligator mouth. So the alligator is going to always open its mouth to eat the bigger meal. So whatever meal is bigger, it's opening its mouth to eat. So in this case, the 2x, whatever it is, we don't know what the x is, that's going to be greater than 10. If there were a line underneath it, then it would be greater than and equal to. So in this case, it's just greater than. So we're going to solve these just like any of the algebra problems we've been doing, except for just a little bit different. I'll show you the difference here in a moment, but we're going to start the same way. We're solving for x, so I'm going to circle the x because that's what I want to find the solution to. I want to isolate it, get it by itself. The x doesn't get along with its coefficient there, which is a 2, so we want to get the coefficient of 2 out of there. So the relationship between the 2 and the x is multiplication. So to get it out of there, we have to do the opposite. The opposite of multiplication is division, so I'm going to divide by 2. Well, if I divide one side by 2, I've got to divide the other side by 2 as well, keeping everything in balance. So 2 divided by 2, that's a 1. So on the left side, I've got an x. We usually don't write the 1, but there's an implied 1 there. It's invisible. You can write it if you want, and sometimes it comes in handy to know it's there. But we're going to leave it invisible for right now because that's too much like training wheels. And then I've got 10 divided by 2. Well, 10 divided by 2 is 5. Notice I didn't bring down the symbol yet, because before I do, this is where it differs, I need to ask myself an important question. The question that I ask myself before I draw it is, did I divide by or multiply by a negative? Again, that question is, did I divide by or multiply by a negative? In this case, the answer is no. So the symbol stays exactly like it was. So we've got a solution there like that. X is greater than 5. And that sort of makes sense. So if x is a 5, 2 times 5 is 10, that's equal to anything greater than 5. If it were, say, 6, 2 times 6 is 12, 12 is greater than 10, so it does make sense, and that is the correct answer. Let's kick it up a notch. What if you have something that looks like this? 5x plus 2 is less than and equal to. So that's the less than and equal to 12. In this case, the alligator's mouth's opening to eat the 12. So this side of the equation is larger than that side, whatever that is. We don't know what it is yet. We're going to solve for the x. So first step is I'm going to circle that x and get everything else out of there. So yes, this is multiplication here, and then I've got addition. Let's get the addition out of there first because it's easier to deal with. So to get it out of there, we're going to do the opposite. If we're adding, the opposite of addition is subtraction. So I'm going to subtract 2. If I do it to one side, I have to do it to the other to keep everything in balance, following what I call the pony rule. Draw my line. So I didn't do anything to the 5x, so I can just bring that straight down. 2 minus 2 is a 0. We could write it, but I'm just going to imagine it there. And I got 12 minus 2 is 10. Notice I didn't bring the symbol down yet, because I need to ask myself that very important question. And that question is, did I divide by or multiply by a negative? In this case, the answer is no. So the symbol stays the same. So now I need to get the 5 out of there. I want to get the x by itself. The relationship between the 5 and the x is multiplication, so I do the opposite. I divide. I divide this side by 5, and I'm going to go ahead and divide this side by 5 to keep it in balance with the pony rule. 5 divided by 5 is 1. I can draw myself a big 1 through there and put my x. 10 divided by 5 is 2. So I'm going to put 2 on this side. And before I bring the symbol down, I ask myself that same question again. Have I divided by or multiplied by a negative? The answer is no. So the symbol stays the same. And so that's our solution there. Okay? And that makes sense because for this side of the equation to be smaller than this side, if I were to plug the 2 in, 2 times 5 is 10, plus 2 is 12, they'd be equal. For it to be smaller, it has to be less than or equal to 2. We've got the equal sign here too, so it can be equal to, but it also has to be less than 2. So 1, if I plugged in a 1, for example, which if x were a 1, this is true. 1 times 5 is 5, plus 2 is 7. 7 is less than or equal to 12, so we know that it's correct. Let's kick it up a notch and do one more problem. Let's do one that looks like this. Negative 6x is greater than or equal to 24. See how we say that? Negative 6x is greater than or equal to 24. So our first step is always, we're going to circle what we're solving for, in this case the the x. I put a circle around it, and I want to solve for the x, and so I got to get the negative 6 out of there. The relationship between the negative 6 and the x is multiplication. To get it out of there, I do the opposite. So I'm going to divide this side by negative 6. And if I do that to one side, I've got to do it to the other. Negative 6 following the pony rule, keeping everything in balance. A negative divided by negative, the signs are the same, so the answer is going to be positive 1. So I bring down this x. There's an invisible 1 here. And I got 24 divided by negative 6. Well, I've got positive divided by negative, so the answer is going to be negative because if you divide and the signs are opposite, it's going to be a negative. And then I've got 24 divided by 6 is 4. So I've got x in some symbol here and negative 4. All right, before I bring it down, I ask myself that important question. Have I divided or multiplied by a negative? Have I divided or multiplied by a negative? In this case, I divided by a negative 6. See the negative 6 there? I divided by negative 6. So the answer is yes, I have. So what happens is this symbol flips around. So many students forget to flip that symbol. You flip it over like that, and then it is all correct. So that is it. You can check it the same way you have in the past. Negative 4 times negative 6 is a positive 24. That would be equal. Does that make sense? Anything larger? If that were, say, a negative, if it were a larger number, then it would still be true. So you can check it that way as well. So that's how you deal with the inequalities that you might face every day in your algebra class. I hope you enjoyed this, and I hope you got something out of it. If you did enjoy it, please click like and subscribe to my channel. If you have any questions or a particular problem you want solved, go ahead and put it in the comments, and I'll even make you a video just with that problem, solving that problem for you. All right, I hope everyone is doing well, and until next time, this is Professor Capko. Thank you.